Question number 27. A part of circuit in steady state along with the currents flowing in the branches, the value of resistances, etc. are shown in the figure. Calculate the energy stored in the capacitor. This is 4-volt battery. Current is coming out 2 ampere. 1 ohm resistor. This is 3 ohm resistor. 1 ampere current enters at this point. This point is P. This is 5 ohm resistor. This is 1 ohm resistor. This is 4 ohm resistor. This is 2 ohm resistor. Here again, 1 ampere current is entering at this point, and here current 2 ampere is entering the 3-volt battery. Now, we have to find out the energy stored in the capacitor. Capacitor is connected here. So if we can find the potential difference across this capacitor, then we can easily find the energy stored. So for this purpose, we have to find out what is potential difference across point P and Q. So let's write it as Vp minus Vs. Suppose this point is S. So Vp minus Vs plus Vs minus Vq. Now, in this branch, total resistance 5 ohm plus 1 ohm, 6 ohm, and current will be here 2 ampere current is coming, and this is 1 ampere current. It means 3 ampere current will flow through this wire. 3 ampere, since capacitance is in steady state, so no current will pass through it. So 3 ampere and the resistance is 6 ohm. So potential difference would be 3 into 6 plus. In this branch, here, this is 1 ampere current, this is 2 ampere current. It means 1 ampere current will come. So only then this will become 2 ampere because this is 1. So here this is 1 ampere. So potential difference across this would be 2 into 1. So this will become 20 volt. So we have found the value of potential difference across point P and Q. Now energy stored will be equal to half CV square. Capacitance is 4 microfarad, 1 by 2 into 4 into 10 to the power minus 6 times voltage square, 20 square. So if we simplify, this will become 2. So this will become 800 into 10 to the power minus 6 joule. Now let's go to next question. Question number 28, part A. Find the potential drop across the two resistors shown in the figure. This is resistor of resistance 300 ohm. This has resistance 200 ohm. This is 100 volt battery. Suppose current I flows through it. So we can find I equal to 100 divided by 300 plus 200. That is 500. So this will be give 0.2 ampere. So now when this current passes through it, so potential difference, suppose this is V1 and here it is V2. So V1 will be I times R1. So I is 0.2 into 300. So this will give 60 volt. And V2 will be I times R2. That is 0.2 into 200. This will give 40 volt. Now, here in second case, this is suppose case A, now case B. Here a voltmeter of resistance 600 ohm. So this voltmeter has resistance 600 ohm is used to measure the potential drop across 300 ohm resistor. This is 300 and in series with 200 ohm. What will be the measured potential drop? So we have to find out what is potential drop here, and that will be measured potential drop. So first of all, we have to find out what is total resistance of the circuit. So total resistance R total will be equal to V has resistance 600 ohms. So 600 into 300. These two are in parallel. Divided by 600 plus 300 in a series with the 200. So this will become 400 ohm. Now we can find the current. So I will be voltage is 100 divided by resistance is 400. So this time current will be 0.25 ampere. Now we can find the potential drop across 200 ohm. Then remaining voltage will appear as potential drop across 300 ohm. So PD across 200 ohm resistor is suppose V1. So V1 equal to resistance times current 200 0.25. So this will be equal to 50 volt. So remaining 50 volt will be measured by the voltmeter. Let's see next question. A galvanometer has coil of resistance 100 ohm showing a full scale deflection for 50 milliampere current. What resistance should be added to use it as voltmeter of range 50 volt and an ammeter of range 10 milliampere? So first case, so here this is galvanometer and we are connecting a resistance R and we have to measure voltage that is 50 volt. Resistance of galvanometer is 100 ohm and full scale deflection current is 50 into 10 to the power minus 3 ampere. Now we can apply KVL. So 50 equal to 50 into 10 power minus 3 times 100 plus or 50 divided by 50 into 10 to the power minus 3 minus 100 equal to R. Now here we will get 50 will cancel out and it will become 1000 10 power 3 minus 100 equal to R, from where we will get R equal to 900 ohm. Now an ammeter of range 10 milliampere. So here there is something wrong in the question. Here it should have been 50. It should have been 50 microampere in place of milliampere. So here we have to remove this term to make question correct, because in second case it will be difficult because ammeter has range 10 milliampere, whereas full scale deflection current is itself 50 milliampere. So let's make corrections. So in place of this, here we will use mu. So when we use mu, in that case, the necessary changes will be like this. Here, in place of 10 power minus 3, we have to write 10 power minus 6. So this term will also change to 10 power. Here it is minus 6 now, 10 power minus 6. So this will become, there is complete change. So this will become 6 zeros minus 100 equal to R, which is roughly equal to R is roughly equal to again 10 power 6 ohm. Now, when we have to convert it in an ammeter of range 10 milliampere, in that case, the circuit will look like this. This is galvanometer. There is a shunt resistance here. Suppose this is S. And then here, total current is given as 10 milliampere, 10 power minus 3 ampere. And the current that passes through galvanometer is 50 into 10 to the power minus 6 ampere. The remaining current I minus Ig will pass through this. So if we apply KVL here, so we can say S times I minus IG equal to 50 into 10 to the power minus 6 times resistance of galvanometer. So our concern is to get S. So S equal to 50 into 10 to the power minus 6 into resistance of galvanometer, and that is given as 100 divided by I minus IG. I is given as 10 into 10 to the power minus 3 minus IG is given as 50 into 10 to the power minus 6. We can neglect this term. So only 50 into 10 power minus 6 into 100 divided by 10 into 10 power minus 3 will be left. Then we can evaluate it. So S will be equal to 50 into 10 to the power minus 6 times 100 divided by in denominator 10 into 10 power minus 3. So this will become 10 will cancel out. This will become 500 into 10 to the power minus 3 ohm, or we can write it 0.5 ohm. So that is our answer. Now let's go to next question. The electric field between the plates of a parallel plate capacitor of capacitance 2 microfarad drops to 1/3 of its initial value in 4.4 microsecond when the plates are connected by a thin wire. Find the resistance of the wire given natural log of 3 equal to 1.1. So here we are given E0 in the beginning, and later on it becomes E0 upon 3 because drops to 1/3 of its initial value. Electric field in the plates between parallel plate capacitance drops to 1/3 of its initial value. It means initial value is E0, and later on it becomes E0 by 3. Time is given as 4.4 into 10 to the power minus 6 second. Capacitance is also given C equal to 2 into 10 to the power minus 6 farad. Now, we know that electric field is given by Q upon A times epsilon naught, and Q can be written as Q0 times e to the power minus T divided by RC, where RC is time constant, divided by A times epsilon naught. Now, in place of E, we can write here E0 upon 3, and so our relation will be E equal to E0. This portion can be written as E0. E0 times e to the power minus T upon RC, but E equal to E0 upon 3. So E0 upon 3 equal to E0 times e to the power minus T upon RC, or e to the power minus T upon RC equal to 1 by 3. Further, we can write it e power T upon RC equal to 3. Now we take log T upon RC equal to natural log 3, which is equal to 1.1 given in our question. Now we can find R. So further, R equal to T upon 1.1 times C. We further evaluate. So R equal to T. T is given as 4.4 microseconds, that is 10 power minus 6, divided by 1.1 into capacitance is given as 2 microfarad, that is 2 into 10 power minus 6. 10 power minus 6 will cancel out. 4.4 divided by 2.2. That will be equal to 2, which is our answer. Thank you for watching.